one.
Hey everybody, this is my third attempt at this, so I'm hoping it works. I'm going to go over and try to explain the process of completing this left side of the column, which is your assignment for tonight, if you don't remember. The starting quantity for the sample mineral was 300 million tons, and that was back in 2005. There's an annual depletion rate of 1.333%. That means every year it loses this percentage from the year before. All right. So it asks for you to make a table. So in year zero, which is our starting point, there are 3 million tons of this mineral. That is our 100%. That's our starting point. That's the 100% from that we're starting with. But we're losing from that 100%, we're losing 1.333%. All right. So I want to know how much is going to be left after we've lost 1.333%. All right. In order to find that, what's going to be remaining? If we're losing 1.333%, what's going to be the remaining percentage that's left? And what you all said in class was, well, in order to figure that out, you need to take the 100% and we need to subtract the 1.333%. And you would have left over 98.667%. So this year, I want to know what is 98.667% of the 300 that's going to be left over. And then from year to year, that's what I'm trying to find. So this is our new, I want 98.667% of this one to get this number. All right. So in our calculator, what that looks like is you take from year zero, 300 million, and you're going to multiply that by what do you want left over? The percentage we're going to have left over is 98.667%. So what is 98.667% of 300? So of means multiplication. And we don't type in 98.667. We have to do the decimal version of that percent. The decimal version of that percent is 0.98667. Because when you move to create a decimal from a percent, you move the decimal point over 2 places. So we did that here, 98.667. We moved it over to 0.98667. We hit equals, and we get left 296.001 million tons of that mineral left over. But now I'm going to lose another 1.333% of this, so I have to multiply it again by the 98.667%, this one, times 0.98667. Gives you 292.055 million tons. And I rounded. The 3 keeps this 5 as a 5. And then I want you to keep going. So you're going to, at home now, do 3, 4, and 5. All right? And then once you have this information, you could now make a graph. And your graph is just going to be an XY axis here. Along the x-axis is years, starting at year 0, year 0, 1, 2, 3, 4, 5. And then you have your amount of millions of this mineral in million tons on this side, and you're going to make a graph. And I want you to think, is that graph going to be rising? Is it going to be falling? You're going to have to decide. Is it going to stay constant? Or is it going to just go real quick, straight up? All right. You've got to kind of decide based on what information you have here, what it's going to look like. And then the final piece is see if you can come up with some sort of quick shortcut equation to find 40 years later. How much of the mineral are we going to have left 40 years from 2005? So 2045. All right. I hope that helps. Please share this with friends if they haven't seen it yet. Show your family. That's it. I'll see you guys tomorrow.